Good morning, this is your Stats Sensei, Mr. Spensei, and this is Death Packet for Unit 3A, Classical Probability, and this will be problems 61 through 70. So the following table shows the joint distribution of random variables x and y. Which of the following statements about random variables x and y is correct? X and y are independent. Oh, so they're asking us about independence. Well, it turns out when I look at this, it's like, oh, times 4 times 2 gives me this. 4 times 3 gives me this. 4 times 4 gives me this. Times 2 times 3 times 4 times. Hey, they're proportional. All right. Because these are proportional, because this is times 2 times 3 times 4, because they're all proportional, they are independent. Now, remember, if something's independent, it means what you know about it, nothing, the past didn't impact the future, or what you know does not impact it. So because knowing the value of x does not change the probability of y, that's correct. All right, let's read the rest of these. X and y are independent because knowing the value of x changes the probability of y. No, that would mean that they were dependent. X and y are not independent. Well, we just said that they were because it's proportional. This is not independent. And it says it cannot be determined. Well, we just determined it is proportional. Now, that wasn't the only way, but that was definitely the quickest way. So suppose probability of x equals 0.35 and the probability of y is 0.4. If the probability x and y is 0.28, what's the probability of y given x? All right, so let's set this up. The probability of x given y equals the probability of x and y over the probability of y. So I'm going to start plugging in what I know. I know x given y is 0.28. So 0.28 equals, and I'm just going to use the intersection symbol for the top part because I don't know that, but I know the bottom part is 0.40. All right, I'm going to solve for the intersection. So I multiply both sides by 0.40, and we find out that the probability of x and y equals 0.40 times 0.28. Great. I'll need this in the next part. On the other side, we have the probability of y given x. Well, the probability of y given x equals the probability of x and y over the probability of x. Well, it turns out I know the probability of x. They told me that was 0.35, so that makes that easy. And we just said the probability of x and y is 0.40 times 0.28. So I just substituted this right there. And when I look for my answer, I'm looking for 35 in the denominator and 0.4 and 0.28 in the numerator. That answer is B. All right, there's a typo on this. Change that 0.09. Yours says 0.09. Change that to 0.08. All right, not 0.09, but use 0.08. So one student from a high school will be selected at random. Let A be the event that the selected student is a student athlete, and B be the event the selected student drives to school. If A and B equals 0.08 and B given A equals 0.025, what is the probability that it'll be a student athlete? All right. So we have the probability of B given A, which equals the probability of A and B over the probability of A. So let's start plugging in what we know. All right. So we know B given A is 0.25. And they said A and B is 0.08. But what we don't know is the student athlete part, which we're just going to call A. Well, if I multiply both sides by A, I end up with 0.25A equals 0.08. Then I divide both sides by 2.25. And I get A equals 0.08 divided by 0.25, 0.32. So my answer choice for 63 is C. But once again, you had to change that, scratch that 0.09 out and make it a 0.08. 64. Probability of A is 0.25 and probability of B is 0.34. What's the probability of A union B if A and B are independent? Oh, well, wait a second. If they're independent, the probability of A and B equals the probability of A times the probability of B. So in this case, we have 0.25 times 0.34. 0.25 times 0.34, and we get 0.085. So the probability of A and B equals 0.085. But that's not what they asked me for. They asked me for the union. Well, I need to go back to my general addition formula, which is the probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. A is 0.25, B is 0.34, and I can substitute this 0.085 right here. So this is going to be minus 0.085. So 0.25 plus 0.34 minus the 0.085, it gives me 0.505. And that's B. Okay, given that the probability of E is 0.32 and the probability of F is 0.15 and the intersection is 0.048, which of the following is a correct conclusion? Well, if I have an intersection, that means I have an overlap, which means they cannot be mutually exclusive. So events are mutually exclusive? No. All right. Are mutually exclusive? No. Determine insufficient to determine whether or not they're mutually exclusive? No, we know that they're not. So it's going to be either B and D. All right. So let's check to see if they're independent. Well, if they're independent, the probability of E intersect F equals the probability of E times the probability of F. Well, the intersection is 0.048. Does that equal 0.32 times 0.15? 0.32 times 0.15. Oh, that's 0.048. Because it equals the intersection, they are independent. All right. So the events are independent, but not mutually exclusive because there's an overlap. Number 66. Suppose that the probabilities that an answer can be found on Google is 0.95, on answers.com is 0.92, and on both websites is 0.874. Are the possibilities or probabilities of finding the answers on these two websites independent? Well, if they're independent, the probability of A and B equals the probability of A times the probability of B. That's true if they're independent. Well, they said for both is 0.874. That's my overlap. And does that equal 0.95 times 0.92? Well, let's find out. 0.95 times 0.92. That does equal 0.874. Because they are equal, they are independent. All right. So yes, because that's a true statement. And an experiment has three mutually exclusive outcomes, A, B, and C. So that means there's no overlap. If A is 0.12 B is 0.61, and C is 0.27, which of the following are um, true? Well, to be independent, there has to be some overlap. Well, there's no overlap on any of these, so they're not independent. The probability of A and B equals 0, well, that's the probability of the intersection. Well, there is no intersection, so that does equal 0, so that's true. So 2 is true. Now, B or C equals the probability of B plus C. Well, we need to be really careful about that. So probability of B or C, that's asking for the union. So B union C equals the probability of B plus the probability of C minus the probability of B and C. Well, B, we know, 0.61. C is 0.27. Oh, there's no overlap, so we're subtracting 0. So guess what? That isn't necessary in this case because they're mutually exclusive. And the reason there's no overlap is because they are mutually exclusive. So this is also true. So our answer choice is D. 2 and 3 are both true. Okay, moving on. Given the probabilities A equals 0.3 and B equals 0.2, what is the possibility of the union of A union B if A and B are mutually exclusive? Oh, mutually exclusive. No overlap. So 0.3 and 0.2. That means I can add them directly. So that answer is going to be 0.5. So we know it's not going to be this one. We know it's not going to be this one. We know it's not going to be this one because 0.3 plus 0.2 equals 0.5. Another way of saying it, probably ought to do it, is say the probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. Well, this is 0.3, this is 0.2, but the intersection, there is no intersection, there's no overlap. So that's where the 0.5 came from. So that's the first part. What if they are independent? Well, if they're independent, we need to remember the probability of A and B equals the probability of A times the probability of B, which in this case would be 0.3 times 0.2. So the probability of A and B equals, should be 0.06, but I'm going to check just to make sure my math is still good, is 0.06. All right. So now I need to use the general addition rule because they're asking for the union. The general addition rule is probability of A union B equals the probability of A plus the probability of B minus the intersection. Well, A is 0.3, B is 0.2, and we just found the intersection. We can substitute that in. So minus 0.06. And 0.3 plus 0.2 minus 0.06 gives us 0.44. Well, both of these have 0.44, so that's not very helpful. So if B is a subset of A, now that's something we really haven't talked about. To be a subset means it has to be completely contained. So what that's going to look like is if this is A, because it's bigger, 0.3, then this will be B at 0.2, but A has to add up to 0.3, so this means this part right here is 0.1. So these two together, what do they add up to be? 0.1, because the 1 and 2 add up to 3. So our answer choice is D. Subset just means it's completely contained. All right. All right, number 69. Given that 49% of the US population are male and 12.1% of the population are over 65, can we conclude that 5.93% of the population are male and over the age of 65? And just out of curiosity, let's take 0.49 and multiply it by 0.121. And that's where they got it. They said, oh, they're independent. That's what they depend. They said the probability of A and B equals the probability of A times the probability of B. And they said, oh, this is 0.0593, and this is 0.121 times 0.49. And that's fine. Now the question is, can we use that? Can we claim that they're independent? And the fact of the matter is, no, age and gender are not independent. First off, the older you are, the more likely you are to die. Secondly, men die younger than women, so they are not independent. Age is dependent upon gender. Women live longer. Not saying they kill the men necessarily. I'm just saying the men die faster for whatever reason, probably because we're stupid and do stupid things. Given the probabilities of A equals 0.3, A union B is 0.7, what's the probability of B if A and B are mutually exclusive? All right, so let's go back to our general addition rule. Probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. Now, if they're mutually exclusive, and this is 0.7, this is 0.3. We don't know B. That's what we're looking for. But we do know that the intersection is 0. So if I subtract 0.3 from both sides, I find out that 0.4 equals B. All right, so that gets rid of these three. We know the probability is 0.4 for B. What if they are independent? All right, well, I don't know B. So let's start off with our formula. First off, we do know this. The probability of A and B equals the probability of A times the probability of B. So let's write our general addition rule. Our general addition rule is the probability of A union B equals the probability of A plus probability of B minus the probability of A and B. But I can substitute this right here. If I do that, now I have the probability of A union B equals the probability of A plus the probability of B minus the probability of A times the probability of B. So let's start plugging in. What do we know? We know A union B is 0.7. We know A is 0.3. We don't know B, and I'm just going to call it B. I'm going to call it 1B. Minus, we know this is 0.3. And we know this is B. Well, I can combine like terms, and then I'll have 0.7 equals 0.3. What's 1B minus 0.3B? That's 0.7B. I'm going to move this to the other side. And I end up with 0.4 equals 0.7B. Divide both sides by 0.7. And I go, oh, I get B equals 0.4 over 0.7, which is the same as saying 4 over 7. So the answer is to 70 is B. All right. Appreciate you watching and hope to see you on the next one. Thank you.